Okay, this is chapter 6, and chapter 6 is dealing with chemical bonding. So let's talk about the different types of bonds. There are two types of bonds that we will be studying. The first one is called ionic bond, and the ionic bond is a bond that is formed between metals and non-metals. One of the atoms is the atom of a metal, the other is the atom of a non-metal. You should realize that a metal is something that has 1 or 2 or 3 electrons in its outer shell. So the metals are ones in group 1, group 2, or group 3. So they have 1, 2, or 3 electrons in outer shell. Non-metals are in groups 4, 5, 6, and 7. They have 4 electrons in outer shell, 5 electrons in outer shell, 6 electrons, or 7 electrons in outer shell. Now, a metal that has 1 or 2 or 3 electrons in its outer shell will tend to lose this outermost electron, and when it loses electrons, it forms positive ions. Positive ion is something that has a positive charge on it. So, if sodium, for example, sodium is in group 1, its electron configuration is 281. Now, sodium has 1 electron in its outermost shell. It doesn't like that. The reason any atom makes bonds is because it is trying to reach the full outer shell configuration of the noble gases. It's trying to have a full outer shell like the ones in group 8. So for 281, if I remove that extra 1 electron in that third shell, I end up with 28, and that means it has a full outer shell. But then that means that it has now 1 extra positive proton, so it has 1 extra positive charge. Now, non-metals tend to gain electrons, and we said non-metals are the ones that have 4, 5, 6, or 7 electrons in their outermost shell. So something like chlorine has 7 electrons in its outermost shell. Now, it has a choice. It could either lose all the 7 electrons, then it would have a full outer shell, or it should gain just 1 extra electron, and that will be the full third shell. So it's easier to gain 1 than to lose 7. So chlorine will gain 1 electron, but when it gains 1 electron, then now it has 1 extra negative charge, so it becomes a negatively charged ion. So the idea of one atom losing electrons and the other atom gaining electrons, this forms an ionic bond, and the ionic bond is the electrostatic attraction force between the oppositely charged ions. If I have 2 ions, one of them is positive and the other is negative, opposite charges attract, and that's something you probably know from physics. Oppositely charged ions will attract each other, and this kind of attraction is called electrostatic attraction force. So this electrostatic attraction force between the oppositely charged ions, or the positive and negative ions, this is actually what we call an ionic bond. So if he says what is meant by an ionic bond is the strong electrostatic attraction force between positive and negative ions. When the atom loses or gains electrons, it becomes an ion. So an ion is actually an atom that has lost or gained electrons. And remember, the atom contains protons, neutrons, and electrons. It will always lose or gain only electrons. We don't lose or gain protons or neutrons. So if it loses or gains electrons, it is no longer an atom, because remember that we said an atom has equal numbers of protons and electrons. Now, when it loses or gains electrons, now it's not neutral, it becomes an ion. And whether it's a positive or a negative ion depends on whether it has lost the electron or gained the electron. So a positive ion is the atom that has lost electrons, because we said if it loses electrons, then now it has extra protons which are positively charged, so it becomes a positive ion, or what we call a cation. If the atom gains electrons, that means it now has extra negative charges, and that is called an anion. Okay? Okay, so let's take a look at this question. Identify the group whose atoms form ions with a charge of +1. In order to form a charge of +1, that means it has gained or lost electrons. To have a +1, that means an extra proton, that means it has lost electrons, and it needs to lose 1 electron. Now, where in the periodic table would the atom lose 1 electron? That's if it has 1 electron in its outer shell. And the one that has 1 electron in its outer shell has to be in group 1. Okay? Do we understand that? So anything in group 1 has 1 electron in its outer shell. It needs to lose it in order to have a charge of +1. Now, identify the group whose atoms form ions with a charge of -1, and we said -1 means that it has gained an extra electron. So which atom in the periodic table would want to gain an extra electron? It gains an extra electron if it has 7 electrons in its outer shell, so that when it gains 1 electron, they become 8, and that's a full shell. So where does something have 7 electrons? If it is in group 7, right? Okay, so the next thing you're required to do is write what we call dot and cross diagrams for these ionic compounds. So if I have lithium fluoride, and the first thing you ask yourself, is this ionic or not? Yes, lithium is something in group 1, so it will have 1 electron out of the shell, and that's a metal. Fluoride means I had fluorine. Remember that as an atom it's called fluorine. When it becomes a compound with something, it is something fluoride. So fluoride is actually the fluorine that is in group 7. So lithium, you look at the periodic table and you find that it is in group 1. It has an atomic number of 3. That means it has this kind of electron configuration where you have 1 electron in its outer shell. Now fluorine is in group 7. That means it has 7 electrons in its outermost shell. It has a total electrons of 9 because its atomic number is 9. But that means that the first shell takes 2 and the next shell takes 7. So lithium has 1 extra electron in its outermost shell. It really doesn't want it, because if it loses it, then the inner shell will be full. So it really doesn't want that electron. Now the fluorine has 7. It needs 1 extra in order to have a full outer shell. So that means that the lithium will lose its electron and give it to the fluorine. And now this fluorine atom has the 7 electrons in its outer shell plus the 1 it took from the lithium. Now when the lithium loses 1 electron, it has extra positive charge. When the fluorine gains 1 electron, it has extra negative charge. So this is your dot and cross diagram for lithium fluoride. Can you see that? So the dot and cross diagram is the final diagram there. Li plus and then F minus, and you have to realize that the Li has lost its outermost shell, outermost electron, so there is no electrons around the lithium in the outermost shell. The fluorine has the 7 that is in its outermost shell plus the 1 extra electron that it took from the lithium. Do we understand this? Usually when we do dot and cross diagrams, we are writing only the outermost electrons. We're not talking about the electrons inside the atom in the shells that are inside. We're talking about the outermost shell only. Okay, so here he's saying I should write the dot and cross for magnesium oxide. So I need to think, okay, magnesium is in group 2. It has a total number of electrons of 12, so its outermost shell has 2 electrons, and it really doesn't want it. Now the oxygen has 6 electrons because it is something in group 6, so it takes these 2 electrons from the magnesium to complete its outer shell, and that means that the magnesium now no longer has electrons in its outermost shell, and it has lost 2 electrons, and that means it has extra 2 positives. You can also write it 2 plus or plus 2. Now the oxygen originally had 6 of its own plus the 2 that it took from the magnesium, and that means it has 2 extra negatives on it. Do not forget to write the charges. Okay? Now I want to write magnesium chloride, so let's think. What is magnesium chloride? Magnesium is something that has 2 electrons in its outermost shell. Chlorine atom has 7 electrons in its outermost shell. So each chlorine needs how many? Each chlorine needs 1 But then the magnesium needs to lose 2. It has to lose 2. It cannot lose just 1. It has to lose 2. So that means it will need 2 chlorines in order to receive the 2 electrons it's going to give. So the magnesium gives the 2 outermost electrons. So it becomes magnesium 2 plus or magnesium plus 2. Now, it needs to give 2 electrons, but each chlorine needs only 1, and that means I need 2 chlorines to receive the 2 electrons given by the magnesium. And that's how you write it. Do not forget to write the charge. When the chlorine gets an extra electron, it's minus 1. The 1 is understood. Don't never write 1. The magnesium loses 2 electrons, and that means it has a charge of plus 2. Please sit down and practice drawing the dot and cross diagrams. This is important. Now, I want to draw a dot and cross diagram for sodium oxide. Each sodium has 1 electron in its outermost shell. It needs to lose it. But the oxygen is something that has 6 electrons in its outermost shell because it is in group 6. And that means it needs 2 electrons. But each sodium can only give me 1, and that means I need 2 sodiums to give me the 2 electrons that I need for the oxygen. So each sodium has lost 1 electron, so each sodium has only 1 plus positive charge. But the oxygen has taken 2 extra electrons, and that means it has 2 minus or minus 2. Do we understand how to think of it? Of course, if he says draw the dot and cross, you're only required to draw the final, not the one where you're thinking what is happening. Okay. You should realize that once the ionic compound is formed, it is in the form of a crystal lattice. So the arrangement of an ionic compound is in the form of a crystal lattice. And the definition of the crystal lattice is, it is a giant 3-dimensional structure with regular arrangement of alternating positive and negative ions. That means if I have, for example, sodium chloride, I don't have just 1 sodium next to 1 chlorine and that's it. Actually, I have a giant 3-dimensional structure with many sodium ions and many chloride ions, and they are arranged alternately, 1 positive, 1 negative, 1 positive, 1 negative, and that means that each positive ion will be surrounded by 6 negative ions, and each negative ion is surrounded by 6 positives. Can you understand that? So each positive ion has negative ions, top, bottom, right, left, behind, and in front. So there are 6 negative ions. And this structure is held together by strong attraction forces between all these positive and negative ions. So in that case, it will need a lot of energy to be broken, and that's why melting point of ionic compounds is very high. So the melting point of sodium chloride, for example, is about 800 degrees centigrade. So ionic compounds have high melting point and high boiling point because of the strong electrostatic attraction forces between the positive and negative The positive and negative ions in the giant crystal lattice, which need a lot of energy to break them and separate the ions. Do we understand that? Now, which one will have higher melting point, magnesium oxide or sodium chloride? The one that has more charges will have more higher or melting point and boiling point, and this is because the higher the charges, the stronger the attraction forces between them. So magnesium oxide, for example, is actually magnesium 2 plus and oxygen 2 minus, while sodium chloride is Na plus Cl minus. So the magnesium oxide will have a higher melting point because of the increased charges on the ions, so stronger attraction forces, and that needs more energy to be broken. Okay, ionic compounds, if we're talking about physical properties of ionic compounds, we said, so here we're talking about physical properties of ionic compounds. We said they have high melting point, boiling point. Another one would be they dissolve in water, but not in organic solvents such as ethanol. Another one would be the fact that ionic compounds conduct electricity. Now, when do they conduct electricity? They conduct electricity only when molten or in solution. Remember, we said the word molten means I heat it until it melts. So if I have sodium chloride solid As a solid, it will not conduct electricity. But if I heat it until it melts, or if I dissolve it in water to form a solution, then it will conduct electricity, and that is because when it is molten or in solution, the positive and negative ions are free to move, while when it is solid, they are not free to move. Ionic compounds conduct electricity when molten or in solution because they have free moving what? They have free moving ions, and this is the only time that you say free moving ions if we're talking about ionic compounds. They do not conduct electricity when solid because the ions are not free to move, because as a solid they are stuck in the giant crystal lattice structure in which the ions are not allowed to move. Okay, the other type of bond is a covalent bond, and this is formed if we have two nonmetals. So remember, if I have a bond and it is between one metal and one nonmetal, do you remember where we find metals and nonmetals in the periodic table? So if one of them is on the left of the periodic table, group 1, 2 till 3, that's a metal, and the other one is on the right side of the periodic table, group 4, 5, 6, 7, then this would be an ionic bond. But if I am talking about two nonmetals, that would be a covalent bond. And a covalent bond involves sharing of one or more pair of electrons to obtain a full outer shell. Remember that in the ionic, one of them lost and the other gained. But in the covalent bond, they're going to share a pair of electrons, or two pairs of electrons, or three pairs of electrons. And the covalent bond is the strong attraction force between the bonding pair of electrons and the positive nuclei of the atoms. So when I have two atoms, each atom has a positive nucleus. Can you see where the nucleus is? Each of the atoms has a positive nucleus. Now when they have a pair of electrons that they're going to share between them, the electrons are negatively charged. So there will be a strong electrostatic attraction force between the bonding pair of electrons and the positive nuclei of the atoms. This attraction force is what we call the covalent bond. So if he says what is meant by covalent bond is the strong attraction forces between the bonding pair of electrons and the positive nuclei of the atoms. Okay, so we need to draw dot and cross diagrams. But to draw dot and cross diagrams for something that is covalent, that is different from drawing dot and cross diagrams for something that is ionic. So if I'm trying to draw the dot and cross diagram of hydrogen molecule, I should remember that hydrogen is something that has atomic number 1. That means it has one proton in the nucleus and one electron. And this one electron is in the first shell. And we said the first shell is full if it has how many electrons? The first shell is full if it has 2 electrons. So actually hydrogen is the only atom that needs only one more electron in order to have a total of 2 electrons in that outermost shell in order to have a full outer shell. So that means that I need 2 hydrogen atoms. Each of them has 1 electron, but if they're going to share these electrons, so these total of 2 electrons will belong to both of them when they share it. And that means that for each atom, it now has a full outer shell. So to draw the dot and cross of this, you can either use circles like this. So we say that I have 2 atoms, 2 hydrogens, and I have a pair of electrons, 1 from each atom, and I draw circles around it in this way. So this is my dot and cross diagram. Or I can draw it without circles, just showing that we have 2 electrons being shared between the 2 atoms. So either that last diagram down there or the one that has circles on the right. Okay? Chlorine molecule. Chlorine, each chlorine atom is something that has 7 electrons. It needs 1 more. So each of them just needs 1 more. So if each of them contributes 1 to be shared between them, then each of them has a total of the 8 electrons that they need, because they're going to share 1 pair of electrons. So either you draw your dot and cross diagram as is shown with the circles intersecting, showing that there is a pair of electrons being shared between them, or you can just draw it without circles, showing that There is a pair of electrons being shared between them, and don't forget to include the rest of the electrons in the outermost shell of chlorine, because chlorine originally had 7 electrons. If it's going to use 1 to share with its neighbor, then it still has 6 other electrons that are surrounding it, and you need to show that. Okay, water. How do you draw the dot and cross diagram for water? Water is something that's made up of oxygen and hydrogen. Now, oxygen is an atom that has 6 electrons in its outermost shell. Each hydrogen can contribute only 1. The oxygen needs 2 electrons, so it needs 2 hydrogens to give it 2 electrons. So that is how you draw the dot and cross with circles for the water molecule, or you could just draw it without circles, but you have to show the ones that are between oxygen and hydrogen are the shared ones. So between each oxygen and the oxygen and each hydrogen, there is 1 from the oxygen, 1 of the hydrogen, and then the oxygen had a total of 6. Remember, if it's going to use 2 to share with the hydrogens, it still has the rest of the 6 to be drawn around it. Do not forget to draw that. Okay, so whichever one you feel comfortable with. If you want to draw it with the circles, that's fine. If you want to draw it without the circles, that's fine. But remember, if you're going to draw it with the circles have to be accurately drawn as shown. Okay. Now, when we share a pair of electrons, that is what we call a covalent bond. So in water, I am sharing 1 pair of electrons each between the oxygen and hydrogen. Each of these one pair of electrons is called a single covalent bond. So actually we say that water has 2 single covalent bonds. Okay, methane. Methane is a compound that has carbon and hydrogen. Now, we should look at the periodic table, and we find that carbon is in group 4, so it has 4 electrons in its outermost shell. That means it needs 4 more electrons in order to have a total of 8. Now, if it's bonding with hydrogen, each hydrogen can contribute only 1. And that means I need 4 hydrogens to contribute 4 electrons, so that my carbon now has its 4 electrons plus the 4 electrons from the 4 hydrogens, so it has a total of 8. And each hydrogen is sharing 1 from 8 and 1 from the carbon, and that means it has a total of 2 in that first energy level, and that is full. You can either draw it with a circle, or you can draw it without a circle. Please sit down and practice drawing these things, and it's important to draw them accurately as it's drawn. Ammonia is a compound made up of nitrogen and hydrogen. Again, nitrogen is something in group 5, so it has 5 electrons in its outermost shell. Now, if it has 5, it needs a total of 8. That means it needs 3 more electrons to make it a total of 8. Each hydrogen can contribute only 1, and that means that I need 3 hydrogens to give me 3 more electrons. Now, I'm going to share between each nitrogen and hydrogen, 1 from the nitrogen, 1 from the hydrogen, 1 from the nitrogen, 1 from the hydrogen. But then the nitrogen originally had a total of 5. It is using only 3 of them to make bonds, so it still has 2 extra that you need to put up there above the nitrogen. Or you can draw it without circles, and please put the shared pair of electrons in between nitrogen and hydrogen. Hydrogen chloride is a compound between hydrogen and chlorine. Okay, so hydrogen chloride is a compound between hydrogen and chlorine. Hydrogen contributes 1, chlorine needs 1, and that means this is how you draw HCl. Oxygen, now oxygen is something that has 6 electrons. It needs 2 electrons, and that means each oxygen is going to contribute 2 to its neighbor, so they're actually sharing 2 pairs of electrons. Now, when something shares 1 pair of electrons, this is called a single covalent bond. So HCl has a single covalent bond. But when something is sharing 2 pairs of electrons, that means it has a double covalent bond, like in the oxygen molecule. So the oxygen molecule has a double covalent bond. The nitrogen molecule has each nitrogen has 5 electrons, so it needs extra 3 from its neighbor, and that means each of them is going to contribute 3 electrons to its neighbor, and that means they're sharing 3 pairs of electrons. This is called a triple covalent bond. Okay, carbon dioxide. Carbon with 4 electrons needs extra 4. Each oxygen has 6, so it needs only 2 from the carbon, and that means that I need 2 oxygens to contribute the total of 4 electrons that the carbon needs. Each oxygen has 6, it will take 2 from the carbon, and now it is full. Remember, you're going to put from the oxygen 2 being shared with the carbon, but it still has the rest of the 6, so you need to put them around the oxygen. So this is how you draw carbon dioxide. And carbon dioxide has double covalent bonds because it is sharing 2 pairs of electrons between each pair of atoms. Ethene is something that has 2 carbons and 4 hydrogens. Now each carbon has 4, it needs a total of 4 more. Each hydrogen can contribute only 1, and that means that each carbon will take 1 from each hydrogen and 2 from its neighboring carbon. So actually the bond between the 2 carbons is a double covalent bond, while the bond between the carbons and the hydrogens is a single covalent bond. Methanol. Methanol is something that has CH3OH. So this is because the carbon has 4 electrons of its own, so it needs 4 more. It's going to take 3 from the 3 hydrogens and 1 from the oxygen. The oxygen has 6. If it takes 1 from the carbon, it needs another 1 from the hydrogen to make it a full outer shell. Do we understand the idea? Please sit down and practice drawing all of this. It's very important. Okay, let's try this question. A molecule of silicon tetrafluoride contains covalent bonds. Draw a dot and cross diagram to show the outer electrons in this molecule. Again, you look at the periodic table, you look for silicon, and you find it is in group 4. That means it has 4 electrons in its outer shell, and that means it needs 4 more. Now, each fluorine has 7, and it needs only 1 more. So you're going to share 1 pair of electrons between each silicon and each of the fluorines, so that the silicon now has 4 extra electrons from the 4 fluorines, but each fluorine has 1 shared with the silicon. Remember, fluorine has a total of 7. If it uses 1 of them for sharing, it still has an extra 6 electrons that you have to put around the fluorine. Usually electrons are drawn in 2s, so it's much better to make them in pairs, 2, 2, 2 around the fluorine. Complete the dot and draw a cross diagram. Show the electron arrangement in a molecule of ethanol. Show outer shell electrons only. Again, you should realize that each hydrogen is going to donate 1 electron. So each hydrogen donates 1 electron. Okay, the carbons are X's. So if it is going to take 1 electron, share 1 electron with each of the hydrogens and share 1 electron with its neighboring carbon. Now the oxygen, have we finished like this? The oxygen has 6. And that means it's going to share 1 with the carbon, 1 with the hydrogen, and it still has the rest of the 6 that you need to put around the hydrogen, around the oxygen. Sorry, is that okay? Okay, covalent compounds now have low melting point and boiling point, so they are regarded as volatile. Remember that the word volatile means evaporates easily. So remember, ionic compounds have much higher melting point, boiling point than covalent compounds. Covalent compounds are usually liquids or gases at room temperature, and except bromine, which is a reddish brown liquid. Covalent compounds are insoluble in water. They dissolve in organic solvents such as ethanol. Covalent compounds do not conduct electricity because they don't have any free ions. They don't have any ions in the first place. So there is absence of free ions. If there is no free ions or free electrons, the compound does not conduct electricity. Okay, what about structures of compounds? Now, the structures can either be simple molecular structure or giant three-dimensional structure. So, many compounds have just simple molecular structure. Simple molecular structure, then it would have low melting point, and this will be because it has weak attraction forces between molecules. Now, remember that melting point, boiling point has to do with the bonds or the attraction forces between molecules. So, something like iodine. Now, each iodine molecule has strong covalent bonds inside the iodine molecule. But that's not what we're concerned about when we're talking about melting point. When we're talking about melting point, we're concerned about the forces between the molecules. So, the fact that it has strong covalent bonds inside each I2 molecule, that does not affect our melting point. It is because each of these molecules has weak attraction forces between them. So, weak attraction forces, we could call them van der Waals forces, or if you just say weak attraction forces, that's fine. Between the molecules, these need a small amount of energy to be broken, and that's why iodine has a very small, low melting point. Actually, it sublimes. Remember we said iodine sublimes. Carbon dioxide. Carbon dioxide also has a simple molecular structure. That means the molecules have weak intermolecular forces between the molecules. We have weak attraction forces between the molecules, which need a small amount of energy to be broken. So carbon dioxide is another example of something that sublimes easily. Other compounds may have, actually they may be compounds or elements, have giant macromolecular structure. A giant macromolecular, so the word macromolecular means giant, okay? Macromolecular structure is a giant three-dimensional structure in which many of the atoms are strongly bonded together. So the examples of giant molecular structure are ionic crystal lattice. Remember we said the ionic crystal lattice is a three-dimensional structure with many positive, negative ions. A metallic structure, the structure of metals, and we'll talk about that. And diamond and graphite are examples of giant structures, and we will discuss each of these in detail. All of these have high melting point, and this is because they have strong bonds between the atoms in the giant structure, which need a lot of energy to be broken. So, ionic crystal lattice, remember we said it looks like this, regular three-dimensional arrangement of alternating positive and negative ions. And this has a high melting point because they are held by strong electrostatic attraction forces between the oppositely charged ions. Metallic structure, a metal, any metal has this kind of structure. A metal is a solid. So remember we said solids have regular rows. But then metals, each atom has 1 or 2 or 3 electrons in its outer shell, which it doesn't really want. So actually these electrons in the outer shell for each atom are just floating around. So we call them delocalized electrons. So the metal is actually made of regular rows of, now that the electrons are a little bit far away, these are not atoms anymore, these are positive ions surrounded by a sea of delocalized electrons. So remember, if we're explaining metallic structure is made up of regular rows of positive ions surrounded by delocalized electrons. Now, all metals have very high melting point and boiling point. Usually their melting point is somewhere around 2000, 3000. Metals have high melting point and boiling point because of the strong attraction forces between what? Remember when we were talking about ionic crystals, we said it's strong attraction forces between positive and negative ions. Here it is strong attraction forces between what? Between the positive ions and the negative electrons. Okay? And this giant three-dimensional structure is rows of closely packed positive ions surrounded by a sea of delocalized electrons. Physical properties of all metals. Remember, if he says give physical properties of all metals conduct electricity, all metals are malleable and ductile, all metals are shiny. First of all metals conduct electricity, both solid and molten. So if you see something that conducts electricity as a solid, it is most probably metal, because remember that we said ionic compounds will not conduct electricity when solid. So all metals conduct electricity, both as a solid and in solution or molten or liquid or whatever. This is because it has free moving electrons, the delocalized electrons, or the free moving electrons, or the electrons that are free to move. This allows metals to conduct electricity. Now you should also know that all metals are malleable and ductile. Malleable means they can be spread into sheets, like the aluminum foil that we use at home. Ductile means they can be stretched into wires. Now, why are metals malleable and ductile? Because the layers of positive ions that we said we have can slide over each other when hit with a hammer, especially when the metal is hot. So the atoms have more energy and are vibrating faster. And we said that all metals are shiny. So let's take a look at this question. Titanium is a metal. The diagram shows the arrangement of the particles in titanium. State why metals such as titanium are good conductors of electricity. We said metals are good conductors of electricity because what? Because they have delocalized electrons that are free to move. Explain why metals such as titanium are malleable. We said malleable is because the layers of positive ions can slide over each other. Do we understand this? Now, another example of giant structures is diamond and graphite. And diamond and graphite are allotropes of carbon. Allotropes means two or more different forms in the same physical state. So they are the same element, and we will say that diamond and graphite are both made of carbon. They only have carbon atoms, and they are both carbon atoms as a solid in the solid state, but they have different arrangement and different structure and different physical properties. So they are called allotropes. So diamond and graphite are allotropes, and fullerene actually are allotropes of carbon. So let's take a look at the structure of diamond, structure of graphite, and the structure of fullerene. Diamond looks like this. So diamond is just made up of carbon atoms. So all of these gray dots or black dots, these are carbon atoms. And they are arranged in this kind of structure, which is called a tetrahedral structure. So if I'm explaining the arrangement or the structure of diamond, first of all, it's a giant three-dimensional structure. So this is not just one atom or two atoms or 10 atoms. This is giant three-dimensional structure, in which each carbon atom is covalently bonded to the other carbon atoms. So there are strong covalent bonds between the carbon atoms in the structure. Now, in diamond, each carbon is covalently bonded to how many other carbons? To 4 other carbons. And in this kind of structure, is called tetrahedral structure, in which we have one carbon in the middle, one on top, and 3 forming something like a pyramid below it. So, if he says, describe the structure of diamond, what do we say? Giant, three-dimensional structure, in which each carbon atom is covalently bonded to 4 other carbons in a rigid tetrahedral structure. And because of this kind of structure, diamond is hard. Diamond is one of the hardest substances that you can find. We actually use it to cut glass because it is very hard. Now, diamond is hard. Why is it hard? Because of the strong covalent bonds between the carbon atoms in the rigid three-dimensional tetrahedral structure. Diamond does not conduct electricity due to the absence of free electrons. It doesn't have any free electrons. Each carbon has 4 electrons in its outermost shell, and it is using all 4 of them to form 4 covalent bonds. So it is covalently bonded to 4 other carbon atoms, so there are no extra electrons for it to conduct electricity. Okay, diamond, because it is hard, it is used in cutting and drilling. So it is used in cutting and drilling because it is hard. And what we said, why is it hard? It has strong covalent bonds between carbon atoms in the rigid three-dimensional tetrahedral structure. Please learn these explanations because these are the common questions that you will have. Graphite, we said, is also made of carbon, but in this case, their carbon atoms are arranged in a different way. First of all, they're arranged in layers. So layers of 6-sided rings. And these layers of 6-sided rings have weak attraction forces between them. So graphite, if I'm explaining the structure of graphite, first of all, giant 3-dimensional structure, in which each carbon atom is covalently bonded to how many? If you look at the structure, each carbon atom is covalently bonded to 3 other carbon atoms in layers of 6-sided rings with weak attraction forces between the layers. So remember that each carbon is bonded to only 3, but each carbon has a total of 4 electrons in its outermost shell. It's something in group 4, so it has 4 electrons in its outermost shell. So if it's going to make covalent bonds with only 3, that means it has 1 extra electron floating around that's not been used for anything. Now, if each carbon atom in this giant structure has 1 extra electron, we have a lot of extra electrons floating around. So would you expect graphite to conduct electricity or not? Yes, graphite will conduct electricity because it has free moving electrons, and this is the only non-metal that conducts electricity. Remember that graphite is the only non-metal that conducts electricity. And because of the layers, graphite is soft. And because it's soft, it's used as lubricant or lubricating agent. And all of this is because of the weak attraction forces between the layers that allows them to slide over each other or to slide past each other. So graphite is soft, diamond is hard. Graphite is used for lubricating agent, diamond is used for cutting and drilling. Graphite conducts electricity while diamond does not. And we said, why does graphite conduct electricity? Because it has free moving, what? Free moving electrons. Since each carbon atom is covalently bonded to 3 other carbon atoms, and the 4th electron in each carbon is free to move between the layers. So, if we say, why is it that graphite conducts electricity? Because it has free moving electrons. Why do ionic compounds conduct electricity? Ionic compounds have free moving ions. Why do metals conduct electricity? Metals have free moving electrons. So the only thing that has free moving ions is ionic compound. Metals and graphite conduct electricity because they have free moving electrons. That is very important. And we said uses of graphite, because it's soft, we use it as a lubricant, but it also conducts electricity, and that is why we use it as an electrode, and this is in electrolysis, and we will be talking about electrolysis in a separate chapter. Another form of carbon is fullerene, and fullerene is a structure that looks like a football, and it is made up of only 60 carbon atoms. So actually it's a small molecule. It's not a huge molecule like diamond and graphite. Diamond and graphite have many carbon atoms. Fullerene has only 60 carbon atoms. They're joined together in a structure of pentagons and hexagons. Do you remember the word pentagon and hexagon from math? Pentagon is something that has 5 sides. Hexagon is something that has 6 sides. So it looks like a football arranged in a sphere. They have lower melting point and lower density than graphite. So these are the structures that you're required to know. So let's take a look at this question. Titanium chloride, titanium 4 chloride, and titanium 4 oxide are both covalent compounds. Titanium 4 chloride is a liquid at room temperature. Titanium 4 oxide is a solid with a high melting point. Explain these properties in terms of structures of 2 compounds. Now, if he says 2 compounds, it doesn't matter what they are. One of them has low melting point, the other has very high melting point. What does that tell you? It tells you that the one that has low melting point has simple molecular structure with weak attraction forces between the molecules that need a small amount of energy to be broken. While the other one, which he said has high melting point, must be something that has giant covalent structure, something like diamond with strong covalent bonds that need a lot of energy to be broken. Do we understand how to answer these kinds of questions? Okay, this is another question. The table shows boiling points of some compounds containing silicon. All of these compounds contain covalent bonds. Silicon fluoride and silicon chloride has simple molecular structures. SiO2 has a giant covalent structure, and that's why from the table SiO2 has a much higher boiling point than the others. Now, first of all, explain why the boiling point of SiCl4 is greater than the boiling point of SiF2. If both of them have simple molecular structures, what would be the difference between them to make one of them have higher boiling point? The only thing would be that the intermolecular forces, or the forces between the molecules in the one with the higher melting point, is stronger than the other one, so it needs more energy to be broken. And that means the one that has a higher boiling point, which is SiCl4, has stronger intermolecular forces, and that needs more energy to be broken. Explain why the boiling point of SiO2 is very much greater than the boiling point of SiCl4. Now, he said that the SiO2 is something with a giant covalent structure. So that means that it has strong covalent bonds that need much more energy to be broken, while the other one, which has low boiling point, has weak intermolecular forces or weak attraction forces between the molecules. So, this is the end of chemical bonding. Please go back and revise this in the notes and try the questions on this chapter. And we'll see you in the next lesson.